Hello everybody and welcome to this week's Easy 11 Plus live lesson on maths from City of London School for Boys. And a big hello as well from, I've got a little foam in my mouth there. A big hello there as well from Dimitri, who's looking very, very fierce and regal today. Look at that flat head. Wow, fearsome. The big news this week is that the 11 Plus Lifeline January sale kicks off on Friday morning. If you want to find out all about that and get the special offer to your inbox, then the easiest way to do that is go into the video description and click on the link to get free resources. Then you'll join my mailing list and then you'll get some mails about the offer from tomorrow evening onwards. The other way, keep an eye on this channel and the community tab there, or simply check the RSL Educational website on Friday and you'll find out the offer. It'll be in a big banner on the website from then. Alright everybody, Dimitri wants to go away and carry on sleeping, I think, so let's get started with today's maths. Hello everybody in the comments. Best of Pro wants to know how Dimby is. Yep, Dimitri is doing very well indeed. He's just sitting on the floor swishing his tail to and fro with an air of slight indignation. Let's do some maths. Okay, so we're carrying on with this paper from last time. If you want to look at questions 1 to 10 being solved, go to last week's video. If you want to look at questions 18 to 20 something being solved, be back next week on Tuesday evening and I'll do the rest. The diagram below shows two overlapping rectangles. Calculate the area of the larger rectangle only. Okay, so this here is, come on work pen, there we are. This here is the larger rectangle, of course. Now to find the area of the rectangle, as with any rectangle, we need to do the width times the height. We've got the height, it's 20. Do we have the width? Well no, we've got 13. Oops, that was an attempt at a circle, but that doesn't cover the whole width. We also need to know what this bit is. How can we find that out? Well, let's look around at what we know. We know that this is 12, and we know that this is 7. So this here is going to be whatever you have to add to 7 to make 12. It's going to be 5 centimetres. And if you look at the rectangle up here on the left, it makes sense, doesn't it? We've got 7 and 5 along the bottom, which add up to 12, which are the same as 12 along the top. So if this is 5 centimetres, then this too is 5 centimetres. 13 and 5 gives us 18. So this is 18 centimetres along there. So the area is 18 times 20. Now we can actually do this mentally quite easily. What's 18 times 2? It's 36. Stick a 0 on the end, 360. So what's the area? 360, well it's given to us fortunately, centimetres squared. Otherwise you need to be careful with units. You think we're doing area, so it's something squared. What are the straight line units? They're centimetres, so it's going to be centimetres squared. But we don't need to worry about that because the answer is given to us. Let's make that into a 0 rather than a strange pot. And we're going a little better. Ashvi says, oh no, I came late. You've only missed part 1 of question 11, so you're all right. Don't worry about it. Lovely to have you here. Hello everybody who's here. Lots of familiar names. Fantastic. Hello Nazreen saying hi, Dimitri and Robert. I changed my name. Did their exam for Christ Hospital. I hope that went well. I'm obviously always, flying the flag for Christ Hospital, and it's lovely to have you here, and I hope that worked out well for you. Okay. Right. Calculate the total shaded area that the rectangles cover. The total shaded area, so that's this complete area there. How are we going to work that out? Well, what happens if we calculate the area of each rectangle? So this rectangle here, of course, we've worked that out. It's 360. This rectangle here, well, it's 12 times 9. What would 12 times 10 be? It would 120. So 12 times 9 would be 108. 108 centimeters squared, because it's 112 fewer than 10 12s. So 10 12s are 120, 9 12s are 108. But of course, you could work that out with a simple multiplication and do it like that. 9 times 2 is 18, 9 times 1 is 9. Add them together, you see, 108. So that works as well. Anyway, it'd be two areas, 108 and 360. But can we just add together 108 plus 360? Can we do that? No, we can't. Because in that case, if we look at this area here, we'll have counted that as part of this rectangle, but we'll also have counted it as part of this rectangle. We'll have counted it twice. We only want to count it once because it's shared by the two. So we need to do 108 plus 360, but we also need to take away once this little shaded area here. Okay? Do you see why? Because otherwise we are double counting it. What is the area of this shaded part here? Well, we can see that the width is 5 centimeters. What's the height of it here? Well, what's the process we've used before? We can see that the height of this little rectangle here is 9. This height is 5. So this must be 4 because 5 plus 4 are 9. 5 and 4 are the same as 9. So this little rectangle here, can you see me outlining it there, sort of, to show which one I'm talking about? That's 5 width times 4 height. So minus 5 times 4. 5 times 4, of course, is 20. So we've got 360 plus 108. What is that? Well, that's actually quite easy because it's 460 plus 8. 468 minus 5 times 4 is 20 is 448, isn't it? So it's 448 centimeters squared. I didn't actually work these out in advance to check them, so I really hope that I am correct. So Libby says, wait, isn't it 468? It's not 468 because, as we've said, that involves counting this shaded area, which is now very scribbled over, twice, because that's part of this rectangle and it's part of this rectangle. So we have to take it away once in order to get the total shaded area. I hope that makes sense. Classic question here. Not too tricky, and once you've seen one of these, you've kind of seen versions of all of them, I think. The diagram shows a rectangle and a square. The diagrams are not drawn to scale. Let's have some coffee. You are not caffeine addicts, so you can get away without it. Right, when I get up in the morning, the day cannot begin until I've had coffee. Terrible. Don't get into that state. Right, diagrams are not drawn to scale. If they have equal perimeters, what is the difference in their area? Okay, we'll come to the second part of the sentence in a second. Let's focus on this. If they have equal perimeters. Well, that's another way of saying they do have equal perimeters, okay? To all intents and purposes. It's a rectangle, so that's 70, so this is also 70. That's 30, this is also 30. What's the perimeter of this? So the perimeter there is 70 plus 70 plus 30 plus 30, which is 200, isn't it? 70 plus 30 is 100, 70 plus 30 is 100, 200. 200 centimeters perimeter. So this here is a square. And if a square has a perimeter of 200, then all the sides must be the same and they must add up to 200. What's 200 divided by 4? Of course, it's 50. So we've got 50, 50, 50. And can you guess what the other one is? I can't. Yes, I can. It's 50. Even I can guess that. Okay. So now we know the perimeters. We know the perimeters of each. We know that each shape has a perimeter of 200, but more important, we know their side lengths, okay? So what's the area of this one here? 70 times 30. So you could go into doing a column multiplication like this, but actually you can save time. What's 7 times 3? 21, basic times tables. Times 10, times 10, so 2100. 21, and then the 0 from the 70 and the 0 from the 30, 2100 centimeters squared. If you're not sure about that, it's fine to do it like this, but the mental approach is fine because it is fairly straightforward, if I dare say so myself. Okay, 50 times 50 to get this one. 5 times 5 is 25. We got a 0 from each 50, so we got 2500 centimeters squared. So these are the areas, 2,500 and 2,100. What's the difference in their area? It's good to show some working for the examiner. So let's do, well, we've shown all our working so far. It's just up here. Now let's show some in the space down here. 2,500 minus 2,100 equals 400. We don't need to do a column subtraction here because that's relatively straightforward. Units, we're talking about areas, it's centimeters squared. They have given that to us, so okay, but always double check because you'll normally need to write your units. You're lucky if they give them to you. So the difference in their area is what we've been asked, 400 centimeters squared. And I'm pleased to see loads of people in the comments agreeing with me. So either we're all wrong or we're all right. Okay, apart from somebody who's wildly wrong, but we'll ignore that. Well done for going out there on a limb and putting your answer in the comments, even if it was a load of rubbish. Right, 13. Calculate the size of the missing angle in this triangle. The diagram is not drawn to scale. You could almost say that questions 13 and 14 are parts of the same question, because actually the knowledge that you use in this question is going to be relevant in the next question. What do we know about angles and triangles? If you know the key fact here, this is really easy. If you don't know the key fact, then you won't get it. So what is the key fact? Let's make this complicated, just for the sake of it. No, for the sake of teaching you something. Let's imagine a right angle triangle for a moment. So why am I drawing a rectangle? This is a rectangle, believe it or not. Because a rectangle, if I divide it into two, makes two right angle triangles. That really should be the corner there. Now it is. Oh, look. What can you tell me about a rectangle? Right angle, right angle, right angle, right angle. 90, 90, 90, 90. What do these add up to? They add up to 360 degrees. Okay. But now I've chopped these two angles in half. Okay, these two right angles. So I've got this and this are the same, and this are the same. Looking at how I've chopped it across there, have a think about why that is. What I've really done, I've taken half the degrees in this rectangle. So I've got rid of this, but I've kept this. I've got rid of this, but I've kept this. And I've got rid of this, and I've kept this. Half the degrees are now in the triangle. So 360 becomes 180 degrees. So a right angle triangle, we can see that has 180 degrees in it. Now the same applies to any triangle. Any triangle contains 180 degrees. So what have you got here? We've got 85 and 33. What are 85 and 33? Well, 8 plus 3, 8, 9, 10, 11. 5 plus 3, 8, so 118. 85 plus 33 equals 118. And we got 180 degrees in the triangle. So if we call this angle, let's just be mathematical, call it theta, which is like an egg with a high belt. We've got an egg with a collar. We have got 180, theta equals 180 minus 118 degrees equals 62 degrees. And that is our answer. Okay? Relatively straightforward, 62 degrees. And in fact, they've given us degrees as a unit there, so we don't need to write it, although you won't lose any marks for doing so. Okay, loads of people agreeing. So the basic thing to remember here, I made it complicated here, just to ram the point home. The basic thing to remember is that there are 180 degrees in a triangle, just as there are 360 degrees in any quadrilateral, any four-sided shape, but 180 degrees in a triangle. Find the size of the angle A in the diagram below at the angle A or alpha or whatever it is. Okay, there we are. Let's call it A to make life simple. How can we do that? Now, what I strongly recommend with a question like this is that you don't puzzle too much about how you're going to get to the answer. You could do it that way, and once you're skilled with these, you will actually be able to say, so that's going to come from that's going to come from that's going to come from that. But just start off filling in what you can fill in. So what can you fill in just looking at this? Well, what are we looking for? So things we can fill in. They might be triangles with two of the angles in, like this. Then you can fill in the other angle. Or they might be Oops, sorry I just rattled the microphone, scraped the microphone there, apologies for the noise. Just bashed it with the end of the pen here, like that. Or they might be, for example, right angles partly completed. So here we have a right angle. You know that that is 90 degrees because that's what that right angle sign means. And if you didn't know that, you do now. But this part of it here is 72 degrees. So what's this part here? Well, logically, it's the right angle less minus the 72 degrees. It's whatever you add to 72 to make a right angle. What do you add to 70 to make 90? 90 minus 72 equals 18. Okay, so this here is 18 degrees. Now again, we're looking for things like partly completed right angles or triangles where we know two angles. Well, now we've got a triangle, this triangle here, in which we know two angles. We know 18 and 19. Okay, what's 18 plus 19? Well, fairly straightforward. 18 plus 20 is 38. One less than that, 37. So this here is so this here is going to be 180, which are the degrees in a triangle. Take away these two together, which are 37. What's 180 take away 37? It's 143. Quite easy, that's take away 40 plus 3. So this is 143 degrees. Now, another thing that it's really useful to know as a rule, but probably relatively self-explanatory if you just look at it. These angles here are the same, 143 to 143. Now, if you don't know that, you can actually still work it out, I think. You can see that this is 143 here. You can see that that one and that one are both halfway around a circle. So on a straight line, so they'd be 180 degrees, half of a circle. 143 plus 37 gives you that. And then you start to work your way around and you can see things that are the same. But I think it's a relatively self-evident rule. When you've got two straight lines that cross each other, this angle and this angle are the same, and this angle and this angle are the same. It doesn't really matter what the angles are. If you've got something really steep like this, still, this angle and this angle are the same, and also this angle and this angle are the same as each other. Okay, the opposite angles are the same. So this one here is 143. Now we've got two angles in a triangle. What's 143 plus 17? 143 plus 17 equals 160. There are 180 degrees in a triangle, as I've shown, and as you must know. So 180 minus 160, giving a bit of working out to the examiner, is 20 degrees. So A here, in fact, let's put it there, just to be clear, A is 20 degrees. And again, the degree symbol is given to us, so we do not need to write it in, otherwise we would need to write it. Oh, how would you describe 100 degrees, acute, obtuse, or reflex? Okay, quick bit of revision of what these things mean. So if we imagine dot, 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 dot. So this is a right angle. Okay, so we go from 0 degrees to 90 degrees to 180 degrees, 90 degrees, 0 degrees. Right, and a reflex angle is less than 90 degrees. So it's something like this. Sorry, not reflex, an acute angle. That's acute. What am I on about? That's an acute angle. An obtuse angle is between 90 degrees and 100 degrees. So it's something like this. That's obtuse. And a reflex angle is more than 180 degrees. So it's like that. Sorry, did I say 100? An obtuse angle is between 90 degrees and 180 degrees. That's what I meant. Reflex angle is a kind of an angle that goes back on itself. So it goes all the way round past 180 degrees. It's an angle where you could take a shorter route. That's a reflex angle. 100 degrees, what's that? Well, 90 degrees is up here. 180 is here. 100 degrees is about there. So it's an obtuse angle. Obtuse. It is not acute, it is not reflex, it is obtuse. Like me when I said the wrong numbers there. I changed my name. Please do stop spamming. It's really annoying. Everyone, please stop spamming. Thank you. It's not too bad for the spamming today, so please stick with not spamming. And stop it, those people who are. Righty-ho. A right angle, more triangles and angles. No, just triangles. A right angle triangle is shown below. It is not drawn to scale, so you can't go measuring with your ruler. Calculate the perimeter of the triangle. You know what the perimeter is. We doubled it already. It's the distance around the outside. If you don't know about area and perimeter, there are videos on these topics specifically in the channel. If you want to find any of my individual topics, then you can search. You can go to YouTube and you could put easy 11 plus perimeter and you'll find something, I think, or just go to my video list. It's in the video description. There's a link to a file called video list, and it's a list of all my videos ever, and there you'll find videos on things like perimeter and area and triangles and pretty much anything you could possibly think of. Not just maths, obviously creative writing, reasoning, comprehension, and so on. Calculate the perimeter of the triangle. Well, that's easy. We add up the distance around the outside. So we do 3 plus 5 plus 5.8. I think there's a bit of a decimals test here. So it becomes 8 plus 5.8. What's 8 plus 5.8? Well, what's 8 plus 5? 13. 13.8. I don't think I'm going to go too much into the intricacies of why here, because it's one of these things. If you don't know about decimals and how to add them, you need to go back and study that separately. And I have videos on decimals. Yes, and on calculations of decimals. And if you do know about it, then this is relatively self-evident. Calculate the area of the triangle. How do you calculate the area of a triangle? If you remember the rule, it's really straightforward. So the area equals half times the base times the height, which equals half times 5 times 3, which equals half times, what's 5 times 3? It's 15, which is 7.5. Okay, so that's quite straightforward. Because it's a right angle triangle, it's actually quite easy to work out, even if you don't remember that rule. Because the area of this rectangle is the width, 5 times the height, 3. 5 times 3 is 15. But the area of this, that's half of the rectangle, so you have to half it. Half it, okay? So with right angle triangles, it's dead easy, because it's really easy to do it from first principles. If you had a triangle like this, for example, and the base was 5, and this was 3, you would not find the area by doing 5 times 3. You need the perpendicular height, okay? Which is this height here. So whatever this height is, okay, let's say it's 2.5, you'd need to do 2.5 for the base times 2.5 the height, and that would give you the area. So really, the formula for the area of a triangle is half times the base times the perpendicular or straight up height, which in this case, because it's a right angle triangle, is the same as the length of that side, but it's not always the same, okay? Just something to bear in mind, because you will, in your career, come across other kinds of triangle. What exciting things are happening in the comments. Abel says, I'm very, 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 very late. 6 times late. It's wonderful that you're here at all. You can always rewind the video. You can rewatch the video in your future life. Do not panic about it. Fantastic that you've joined. Anybody who's along here who isn't in the live comments and wishes they were, you just have to subscribe to the channel. It's completely free. Just click subscribe under the video. You become a subscriber and then you can take part in the live comments. Simple as that. The diagram above is not drawn to scale. Again, very annoyingly, they like their diagrams and they like not drawing them to scale. The box measures 20 by 11 by 15. Okay, calculate the volume of the box. It's all in centimeters. So how do you do this? This is just a test of whether you know the basic principle here. Width times depth times height. Multiply together. 20 times 11 times 15. Okay, multiplication is commutable. You can do it in any order. Let's say, I don't know. We could do this by column multiplications. Let's practice a bit of mental arithmetic, especially because I haven't prepared this, so prove to you that it isn't that tricky. Doing times 20 is easy, so I'm going to save that for the fiddlier numbers. So I'm going to stick the 20 times. What's 11 times 15? 11 times 15 is really easy. 2 easy ways to do this. One is to do 10 times 15, then add another 15. So 150 plus another 15, 165. Another way is to do 10 times 11 and then add half as much again. Okay, that gives you 15 times 11. 10 times 11 is 110. Half as much again, another 55. 165. So you get 165 either way, okay? So you've got 20 times 165. How do you do that? Easy, times it by 2, stick a naught on the end. How do we times 165 by 2? What's 160 times 2? 320. 2 plus 16 is 32. 2 plus 116 is 320. Plus an extra 10 because we've got 5, 330. Look, there is absolutely no shame in doing 165 times 2. And in fact, it might be worth doing that when you're under exam pressure in order to avoid making mistakes, because that way you can just be confident of it. So we do 2 times 5 is 10, 2 times 6 is 12, plus 1, 13, 2 times 1 is 2, we got 1, so we've got 330, okay? It's really quick, there's no shame in doing that. And do not, here's a good rule for exams, do not do mental arithmetic beyond your point of certainty. So only do something mentally if you're certain that you will get the right answer, or as near to certain as you can possibly be. Otherwise, use a paper method like that. Don't try and do the mental arithmetic just to prove to yourself that you're smart. An exam isn't the time to do that. It's more about practice than smartness anyway. Much more about. Okay, so the volume of the box, 330 centimeters cubed, which again is the width times the depth times the height. Easy peasy. Got to write the volume centimeters cubed, except that they've given it to you. The units, sorry. A string is tied around the box with a bow at the top, as shown in the diagram. If the length of the bow is 8 centimeters, something vaguely poetic about the way this is worded. I can't quite pin down what it is. Something in the rhythm and the repetition. A string is tied around the box with a bow at the top, as shown in the diagram. If the length of the bow is 8 centimeters, calculate the total length of string used. Yeah, just a little bit of tweaking and you've got a bit of Dr. Seuss there, haven't you? Maybe quite a bit of tweaking. What am I on about? What am I even on about? I just want to be doing English, don't I? That's clearly what it is. Okay. Total length of string. So, well, let's have a look at it. Let's look at this belt that goes around it that way, first of all. So we've got 20 along the bottom, 15 up, and half of 20 and half of 20. Add them together, make 20. So look, you've got 20 at the bottom, 20 at the top, 15 on each end. That's pretty straightforward, isn't it? 20 plus 20 plus 15 plus 15. Now, I'm going to put this in brackets just so it's easy to categorize that as sort of round that way. Now we're going to do the one that's round that way. Okay. So we're going to add that on. So we got 15 and 15 at the back. And we've got 11 along the top and 11 along the bottom. So you've got 15 plus 15 plus 11 plus 11. So we're adding those on. And then we've also got 8 centimeters to add on at the end, which is the length of string used in the cute little bow there. So plus 8. How do we add all these up? We could do an enormous column, or we could try and do it all at once. I prefer a middle ground, which is that we do it mentally, but we break it into chunks. So 20 plus 20 is 40, 15 plus 15 is 30, 15 plus 15 is 30, 11 plus 11 is 22, plus 8, and then we do it some more chunks. What's 40 plus 30 plus 30, 30 plus 30 is 60, plus 40 is 100, I hope you got that, plus 22 plus 8 is 30, oh look, it's 130, 130 centimetres, okay? Relatively straightforward. Robert, you are wrong. It is 3,300, not 330. What have I done? Oh, blimey. Thank you for the correction. That is most embarrassing. Yes, you are quite correct. I did 2 times and forgot to times it by 10. Oopsie daisies. You forgot to add the 0. Thank you for the people in the live comments. How embarrassing. Well, that's what I have you here for. That is also, ladies and gentlemen, why I really should prepare these lessons by doing the questions beforehand. And I shouldn't get carried away with other work and go, oh no, I'm in a rush before the thing, and not prepare them all. Yes. Thank you, all of you, for your comments. Libby, everyone makes mistakes. Yeah, but they shouldn't really make mistakes when teaching maths in a live YouTube lesson, because they should have checked beforehand and preempted the problem and not made the mistakes when live, corrupting the young with their bad maths. Thank you, people. Right, onwards. Okay. Right. We got a list of numbers. I think we can see what kind of question this is likely to be. Let's see whether it is. Right, one number from 20 to 30 that satisfies the descriptions below. Bit wordy. I think we'll work out what it means. So some numbers are used more than once. Okay, just bear that in mind. So the fact a number's been used doesn't mean it can't be used again. Prime. Okay, I think we know what this means now, don't we? Even if the wordiness is a little tricky. We're looking for a prime number from that list. We only need one, so even if there's more than one option, we only need one of them. What's a prime number from this list? Well, the only even prime is 2, so it's going to be an odd number. What is a prime number again, people? It's a number that can only be divided by itself and 1. So, for example, 3 is a prime number because it can only be divided by 3 and 1. You can't divide it by 2, you can't divide it by 4, or 5, or anything of that sort, okay? Well, you can, but you won't get a whole number, okay? Its factors are itself and 1, and nothing else. There are more mathematically sophisticated ways of describing it. Let's avoid those. Odd numbers. 21, nope. 3 and 7. 23, yes. Good. In fact, that's the only one you have got here, so you better have written 23 because otherwise you are wrong, like I was wrong on the question before. By the way, I forgot to mention it at the beginning. The worksheet for every lesson is always linked in the video description, so you can always download it and have a go yourself. Now, even better than that, if you want to get on my mailing list and get a copy of the worksheet for every lesson in advance, usually when I'm organised on the Saturday morning before each lesson, then there's a really easy way to do it. In the video description, there's a link for free resources. Okay, it says get free resources. You click on it, you enter your email address, and that also, not sneakily, I do tell you when you do it, it also puts you on my mailing list. When you're on my mailing list, it means you get these worksheets, among other things. So if you want to get the worksheet before the lesson so you can have a go beforehand, which is a very useful way of studying, do that thing. Cube numbers. What is a cube number? A cube number. So we sketch a cube to remember. Here's a little square. And we turn it into a cube. How would you find the volume of a cube? 2 times 2. Oh, yeah. It's this. A cube number is like the volume of that. 2 times 2 is 8 centimeters cube. A cube number is what you get when you times a number by itself and then by itself again. Yes, that's the one. So, for example, if we had 2 times 2 times 2, that's 2 cubed. And it's 2 times 2 is 4 times 2 is 8. So 8 is a cube number. 2, we wouldn't say that's a cube number on the basis of this because then anything could be a cube number because you could say 1.2 times 1.2 times 1.2 or whatever. Or, you could say, 5 times 5 times 5. So 5 is a cube. No, it's the answer that's the cube number. Just as, for example, I don't know if I did 5 squared, it's 25. It's 25 that's the square number. Okay? Cube numbers. So 2 times 2 times 2 is 8. Don't go through all these numbers testing them. That is not the best way to do it. What's the next cube number? 3 cubed equals 3 times 3, which is 9 times 3 is, what? That's not times. 27. That's up here. We got it. 27. Okay, that's the only option here. Square numbers. You did what a square number is. So what have we got? We have got, 4 times 4 is 16. 5 times 5 is 25. Oh, yes, there we have it. 25. Fibonacci numbers. Fibonacci. Or Fibonacci, as we say in English. Fibonacci. Fibonacci. See how badly we can mispronounce it. Fibonacci. Fibonacci numbers follow the sequence 1, 1, 2, 3, 5, 8, 13. What is the sequence there? You may have studied this, but you can probably work it out from looking at them. At each stage, we're adding together the 2 previous results. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21. Oh, look, it's 21. That's the answer that we want. Of course, the next one is going to be way beyond 28, so it is not useful to us. Triangular numbers follow the sequence 1, 3, 6, 10. Okay, so what is the rule here? Well, triangular numbers, they're an addition thing, really. What's happening is, so for the second place, for example, it's 1 plus 2 is 3. For the third place, it's 1 plus 2 plus 3 is 6. For the fourth place, it's 1 plus 2 plus 3 plus 4 is 10. But another way of looking at it is that we're going up by 1 more each time. 2, 3, 4, 5. So the next one, 6. 15 plus 6 is 21. Plus 7, 28. Okay? So we could also apply that rule. The answer is 21 or 28. You can use the same number more than once if you want to. It doesn't really matter. 21 or 28 will be fine. A perfect number is a number whose factors, not including itself, add up to itself. Okay, so its factors add up to make a cohesive whole that is itself. This is like you, Nathan Okai, in the comments. All the factors, the components of you add up to make the perfect whole that is you. My perfect live commenter here. You are a perfect number. Right, so 6, its factors, 1, 2, 3, they're the only factors of 6. If you're not confident with what factors are, go and watch my video on it. I'm not going back to the basics here, but basically the factors are all the numbers that you can, whole numbers that you can multiply by something to make 6, okay? Not the prime factors. Yes, the prime factors, but also the other ones. And we're counting each factor only once. Okay, 1, 2, 3 gives 6. So, yeah, let's have a look at some of these options. Right, now at this stage, this is going to take quite a lot of fiddling. So this is exactly the kind of question where in an exam, I would be very tempted to say, skip this and come back to it at the end, because you could waste a lot of time on it. But this actually is pretty much the end. We're getting to some of my 11 plus lifeline publicity afterwards. We're getting to the end of the questions we're looking at today. So let's just brute force it now. I don't think there's an easy way through this apart from just working it out from the different numbers here. So what have we got? We've got 20 through to 28. So let's have a look. I think what will happen is we'll get quick at it as we go. So 20, what are the factors? 20, we got 1, we got 2 because it's even, not 3, yes 4, yes 5, not 6, not 7, not 8, not 9, yes 10. 10, 15, 19, 20, 21, 22, okay? So we're very close to having 20, but not quite. So the factors do not add up to 20. 21, what about this? 21, obviously 1, not 2 because it's not even, 3 because 3 times 7, 4, 5, 6, 7, 8, 9, 10. So it's just these 7, 8, 9, 10, 11. They don't add up. That isn't 21. 22. What have you got here? We got 1. We got 2 because it's even. We haven't got 3. And we've got 4, 5, 6, 7, 8, 9. We've got 11. 11, 12, 13, 14. Nope, doesn't add up. Okay, so we're going really quickly here, really. 23, it's a prime number, so good luck with that. We've just got 1. 24, what about this one? We've got 1, we got 2, we got 3, we got 24 has got loads of factors. 4, 5, 6 is, 7 is, and 8 is, 9, 10, 11, 12. Okay, so add these up. 12 and 8 is 20 plus 6. We're already way over. Okay, 24 was going to exceed it. It had that tendency. 25, we got 1, we got 5. Okay, 5 is a factor of 25. 5 times 5. Anything else? 1 and 5, 6, 7, no. Nothing else is going to go in there. It's not going to be that. 26. So you said, about this being one to leave for the end. So we got 1. Yes, we got 2. Yes, because it's even. 3, it doesn't divide by 3. No. 4. No, doesn't go in there. 5 doesn't. 6 doesn't. 7 doesn't. 8 doesn't. 9 doesn't. 10 doesn't. 11 doesn't. 12 doesn't. 13 does, because half of it, 13, 14, 15, 16. So those that added up 26. Struggling to find a perfect number here, but we have faith. 127 does. 1 doesn't. 2 doesn't. 3 does. 4, 5, 6, 7, 8, 9 does. 9. Okay. 10, 11, 12, 13, 14. Nope, 9, 10, 11, 12, 13 doesn't work. Whoa, still not there. 28, what about this? Come on, come on. 1, 2, 3, 4 does. 4 does go in there. 5, 6, 7. Okay, 8 doesn't, 9 doesn't, 10 doesn't, 11 doesn't, 12, 14 does. So 1, 2, 3 plus 4 is 7, plus 7 is 14, plus 14 is 28. 28 is. Okay, so that's the one we're looking for. 28 is a perfect number. So brute force was our way here. If you were lucky and you started from the top, you'd get there a lot faster. I don't think there's an easy way to see this one. I think you just have to try it out. Woof! Very well done to anybody who got 28 there. A powerful number has the property that for every prime number which divides into it, that prime number squared also divides into it. Okay, this is an example. Let's just look at the example. 16 is a powerful number because 2 and 2 squared are factors. So hang on. The only prime number that goes into 16, yeah, it's 2. Okay? Factor 16, 1, 2, 4, 8, 16. Okay, only 2 is prime, and 2 is a factor of 16, and 2 squared is 4, and 4 is a factor. Okay, so 16 is a powerful number. Got it. Right, let's try these ones up here. We're starting at, what are we starting at? 20. Now we've actually, the working for the last question is going to help us here because it shows us the factors of our options here. 23, let's add 1 and 23 just so we got those there to look at. Right, so 20. What are the prime factors of 20? 2 and 5. Well, 5 squared is not going to be a factor of 20 because it's bigger than 20, so we can eliminate that. 21, we've got 7 in there as prime. 7 squared is 49, that's bigger than 21, so it's not going to count. 22, we got 1, 2, 11. 11 squared is bigger than 22, not going to count. 23 is prime, and 23 squared, nope. 24, we got, what do we got here? What's prime in there? We got 2 and we got 3. Well, 3 squared is 9, and 9 is not a factor of 24. 25, we've got 5 is a factor of 25. 5 squared is 25. That is a factor of 25. So 25 is an answer. Okay, because we're at the end, let's check if whether there are any others. 26, we've got 2 and 13 is well, 13 most certainly not. 13 times 13, 169. That is definitely bigger than 26. Nope. We got 1 and 3 here. Okay, prime number here, factor of 27. 3 is a factor of 27. 3 times 3 is 9. That is also a factor of 27. So that counts. So 27 would be an answer as well. 28, 2 squared, 7 squared. Nope. Okay, so 25 or 27 would be answers here. Powerful numbers. Poof. That was a funny one. I don't think those were generally really difficult questions, even though I did manage to make a pratfall in this one here and get it wrong. Thank you for everybody who pointed out that I'd missed a 0. But in general, I think the main thing here is it's testing quite a wide range of knowledge. And you need to know some key things. For example, that there are 180 degrees in a triangle, that you find the area of a triangle by knowing the half times the base times the perpendicular height. Things like that. If you've got a good grasp on that kind of thing, then you'll do okay. But it's just having all that core knowledge lined up. All right, let's zap on to today's. Very exciting, the tip of the week. I'm going to shamelessly exploit the tip of the week to remind you that the 11 Plus Lifeline January sale begins on Friday. So on Friday, check in on the RSL educational website. All the links are in the video description and you'll find the offer code there on a big banner. And you'll be able to get 11 Plus Lifeline, which I hope, because I've made it so, is very useful for your 11 Plus preparation and offers you all kinds of things. It offers you resources with detailed solutions every single week. It means that you can send me work for detailed individual feedback with me talking and giving you little videos on your work and telling you exactly what to do and encouraging you. All these things, you can have it at a humongous discount if you check in on Friday. The other way to get the offer, join my mailing list. I explained that before. Go into the video description, click on the link for the free resources, sign up, you'll get on my mailing list and you'll find out all about the offer. What could be better? So yeah, my tip of the week is get 11 Plus Lifeline at a really big special offer. I'm afraid it's only for people who haven't signed up in the past or aren't already signed up. Sorry about that if you're already a member, but otherwise, come along and find out what it's all about. You can always try it and cancel later if it isn't for you, but I've designed it to make it useful for, I hope, absolutely everybody who's doing the 11 Plus. And that's the tip of the week. Shameless, wasn't it? What have I got in the way of questions? Anna says, can I get a shout out? It's my exam tomorrow. I'm sorry, I don't give shout outs to people who ask for them. So Anna, I cannot give your name here. Any other questions sitting in there in the chat? No questions yet, no questions yet, no questions yet. Okay, 5, 4, 3, 2, 1. Yes, no questions yet. Brilliant. That's only the time lag, I know, in the comments, but I'm going to take it as an excuse because I'm pretty tired. You're tired. It's January. Who wants to make these lessons drag on any longer than they have to? 45 minutes. Already painfully long for you people who are being made to watch this by your cruel parents. You want to get away and say that you've watched it and eat your dinner. So let's let you do that. It's been fantastic to have you here, people. Check out all the links in the video description. Don't forget the 11 Plus Lifeline sale with a really big discount starting on Friday. Give it a try. If you're not sure, you can cancel in the first month and get a full discount. Yeah. That's enough for me. Is Dimitri around to say goodbye? He is not. So I'm just going to say goodbye myself. It's been really good to have you here, and I'll see you next Tuesday evening at 6 o'clock for the next Easy 11 Plus live lesson, in which we're going to be finishing off this maths paper with the harder questions at the end. All right, see you soon. Have a great week. Bye-bye. This is why I drink some coffee while the video finishes playing out, because there's that time lag and I don't want to chop off the end of my voice. Okay, that's probably good enough.